we do model training, and from analytics we do textual, user information, temporal, spatial, and network graph from that information. So these are the general architecture that I'm going to present for all the systems that we have developed here. So the first of our effort is the Unmark, which is a collection of large-scale Ubuntu we presented in GIFs. So it's a repository of, we have been collecting data for the last 3 years from the Twitter, but first phase was a bit experimental. So we have like 106 million Urdu tweets from September 18 to August 20, and after that we are still capturing the data. It contains 16.72 million hashtags and 5.6 million URLs, and 71% of the tweets are actually unique tweets. So these are general information. We have open sourced that data at SourceForge, so anybody can download and use this data and then do some analytics. So one of our contribution of our lab, we try to make all data resources and tools open source so that other people can contribute as well. So these are general statistics that we have found from Unmark. This is like a one-day pattern. So you can see really a time of day effect. The time of day effect is that people are mostly using from 8 a.m. to 8 p.m. and then we have like slightly less usage. And then we also found that over weekend there is less usage, so which is quite consistent what is in reality. So these are the, what you're seeing in this graph, this is one line is actually one day. So these are the hashtags that we are observing. So we wanted to, we are interested in that how we are observing that how many hashtags are new. The new hashtag means that something has happened today and people are discussing that. And the yesterday means that something has happened yesterday and it's still interesting, so that people are still interested. So that is even, so let's say right now FIFA World Cup is going on. So that hashtag is actually running since a month. And maybe it will be running like 1 week after the event. So if I zoom into one portion of this, what we observe is that the 57K we observe 57K unique hashtags. Hashtag is the one trend that we see in Twitter. And we have like 16.7 million tweets, and around 20% of the hashtag have more than 6 months lifespan. They are reoccurring again and again. So we have deeper analysis in the paper, but for the time, for the short time, we haven't discussed the rest of the details. So the first of the system, so now what I have established that we have a database of Twitter and data, and then now we can pull out multiple information from it and develop multiple systems out of it. So the first system that we developed is the epidemic surveillance system, ESS. Normally in health sector, the surveillance systems are already there. The people, what they normally do, they collect data from the hospitals, and then they generate reports, and then they actually do some decision making. So this data is very important for decision making. But the problem is that it's not real time, and you maybe Dr. Gulani said it takes weeks or maybe months, right, to get the real picture of the data. And then it's a really human resource intensive. So you need to ask a lot of people before you get that data. And then this data is not available, as you said, this data is not available for public because there might be privacy issues and other issues, right? So if you want to build a low-cost, real-time system, then you need to go for some alternatives. And the first alternative that we think is Twitter. It's a free resource. It's publicly available. You just need to get some tools to analyze it. And the motivation for doing that was, there were multiple motivations. So, and I have to mention that we were doing it before COVID. We started in 2018, developing this, and we were working on that. And then the COVID came, and then the whole scenario actually changed. So what you can see here is that in Pakistan we have polio disease. So it re-emerges, then it finishes, then it re-emerges sometimes. So people do lots of, then you need to actually find some hot spots that where the disease actually has. And then again, with the COVID-19 vaccines, so the role of information, social media was really important. There was some information was being spread against the vaccine. In order to build a system for epidemic surveillance, we collected data. We collected data for both English and Urdu language, and we filtered them and we stored them in a database. We scheduled periodic jobs to collect the data, and then we designed a database, and then the database contains both English and Urdu language tweets. And the distinction of our work is that we manually labeled 42K tweets. So as all the people who are working in AI, the gold set data is very important. And generating gold set data is actually more time consuming than generating the model itself. So that's really a painstaking step. So we manually labeled 42K tweets, both in English and Urdu languages, for 5 diseases. So we focused on, initially we were focusing on flu, but then after COVID-19, the flu was all merged with the COVID-19. So we actually had, again, changed it to COVID-19, and then malaria, dengue, HIV, and hepatitis. These are the 5 prevalent diseases in Pakistan. So these are, if you go there in Sindh, I will show you the map. In Sindh, we have a lot of problem with HIV. In Punjab, in some time, we have lots of problem with dengue. And hepatitis B is actually, these are actually more consistent all over the country. So what we did, when you see data doesn't tell you that if it is talking about some indication or if it is talking about some general discussion, right? So we manually labeled all those tweets which are indication class and general class. We divided that. That's our contribution. Because the indication tells you, so for example, if somebody is saying that I'm affected, or if somebody is saying that there 5 people died of, let's say, COVID-19, so that is some kind of an indication that something is going on that areas. So our contribution in this system is that we actually try to figure it out that how we can separate indication and general discussion. Right? And then in the general discussion, we discuss prevention techniques, outbreaks, news, past cases, past statistics, and the indication tells you what really when there is some casualty or some symptoms are there. Right? And then we train some machine model, learning models using labeled data set. So this is how generally it works. We process 120 million tweets related to disease. We geotag them. Some of them tweets were geotagged, and then we use a multi-threaded API using Python, and then we will develop a model, and then we have our own system running. So this is a system that we are showing here. And what you are seeing on the top is the tweet rate that we are getting, and then we are dividing this into multiple diseases. We are classifying into, and then we have over the full Pakistan map. We can see that where is that outbreak is most prevalent. So in the next slide, I will show you. So you can see here that at the time we took this picture, the COVID was the most common. Zoom into 2 graphs. So see there on the left side we are showing the disease classification. That means that how many data in this. In case of COVID-19, we are getting like 80% or 85% data as a general discussion. But we are also getting like 15% data where we are getting some indication. And then we divide that indication into different areas and see where are the hotspots. And similarly on the right side, what you can see here is that we are dividing this into different areas, that in which province how much indication is there for a particular disease. So now we can establish the whole surveillance. And this system is really useful for the health authorities and for those who really want to see that where are the outbreaks. So our system has a capacity to predict before the outbreak actually becomes a real problem. So this is the first system that we have developed. And the second system that we have developed is the hash scope. Hash scope is similarly, it's a system that gives us some visibility into what is being discussed and how it is being discussed over the social media system Twitter. So this is the hash scope architecture. So what we do here is that if we have used Twitter, so on Twitter what happens is that they have a trending panel. So trending panel means that if you are discussing something, if a lot of people are discussing something on one topic, they will show you as a trend. And this trend is very important because that tells you the pulse of the society, that how people are actually, even how people are actually thinking about a particular topic. So what we observe is that, especially in Pakistan, there are 7 categories of hashtags. So first we observe that they are political, then we have sports, military, people are discussing about military, and then we have some entertainment, campaign, and some religious issues also. The third thing that what we do was the user classification. So once we know that this is a topic related to an X category, then we wanted to understand that what are the type of users. One, they may be bots, they may be micro-influencers, they are trend promoters or normal users. I will discuss all these users in the next slide, and then we can get our overall analytics system. So what Twitter Trends does, Twitter Trends provides hashtags and keywords related to events which has a sudden increase in real-time mention. And they provide some breaking news, some social events, sports, some political personalities, and whatever. So the idea was that we wanted to understand that how fake news are spread over the social media or over the Twitter. So these are the social media. On one side they are helpful, on the other side they are also used as a fake news spreader. And fake news has lots of issues. So globally it is said that 20% of the global Twitter trends are inorganic. Inorganic means that there is somebody behind that. There is somebody behind that effort to bring it into the trending panel. And why they want to bring it into the trending panel? This is a big question. There are some hidden motives. So the hidden motive is that people want to do some opinion manipulation. So they want to really, as I said, your attention is a commodity. So your brain is being programmed to think about something or to believe about something. So that's what we call as a manipulation. So what people do, they do fake trends for public opinion manipulation, for political maligning, and for economic benefits, and for fifth generation warfare. I will actually explain all these things in the next slide. So why this is a problem for Pakistan? So there is one study, the whole one, on July 4th, a hashtag calling for the arrest of journalists become the top trend in Pakistan. So what people do here is that there are keyboard warriors. What are these keyboard warriors? These keyboard warriors are they set a time. Okay, at this time we will collectively do some tweets and retweets, and we will amplify a particular hashtag, and then what they do, once it's in the trending panel, then the rest of the public is there to discuss. Then the people can then now do their opinion, and then they take over, and the original people who start, they just sit quietly and see what other people are doing. So they are they just ignite the fire and then leave. So these are the examples that what we are observing is that there are some hashtag wars. So how these are wars? These are political wars being fought on the social media. So what we observe is that so these are like two major parties. So we observed one hashtag at 6 p.m. and then at 10 p.m. you have an answer. So these are from two different parties. Like for example, this is the original hashtag, and then we get the counter attack. So that's how people attack. So and then they build narratives. So again, the next thing is that this problem is not national problem. This is an international problem. How is it an international problem? That at sometimes we get cross-border infiltration in our digital space. So people from India, from Afghanistan, so they come here in our digital space, and then they try to discuss those things that are actually anti-Pakistan. And their IDs are, they hide it like Pakistanis, but they are not. So disinformation war is a fifth generation war. And there are cells in India and other countries that they do this disinformation. So we wanted to detect that information by using artificial intelligence. So this is our first worked in that where we presented a hashcat. Hashcat is a hash category, trend category defining or finding tool. So every hashtag has a story, and we wanted to go behind the story that what this topic is related to. So we did, again, we have some 7 categories: political, sports, religious, campaign, entertainment, and military. So we collected data over the period of time, and then we did our modeling. So we developed actually 3 classifiers, and then we added them. So first is the text classifier, just looking at the text, and then we have a co-occurrence classifier. Co-occurrence classifier means that sometimes what happens is that the 2 hashtags that they co-occur, and then their co-occurrence has some meaning. And then we check the segment similarity, that if we have 2 tweets and we divide into segments, and if they overlap, then we can actually see that they are correlated. So, and then we combine them into a hashtag with some, and then our combined model is then it can give us if the hashtag was political or sports or religious. And then in other words, we try to understand the political micro-influencer. As I said, that every hashtag has a story, but someone is actually making up that story in political case. So we wanted to go behind those micro-influencers, that how they are doing that. So micro-influencers are actually different types. There are some regular users, some creators who are genuinely making some money. I mean, they're bloggers, it's their business. And then we have influencers. What they do, they have some brand awareness, product validation, social awareness, and product reviews. So in Twitter, there are 2 other phenomena which are important. One is the bots, and the other one is the micro-influencers. So what bots do is that normally 20 to 29% of the data of the content is created by bots. Bots are just like machines which you have programmed, or that you can just order them and then they can start using the application. So what they do, they use phishing, and they do falsely amplify the influence, generate fake trends, and create false narratives. So micro-influencers are, the macro-influencers are costly and diverse audience. So let's say if anyone has 1 million followers, that guy is actually a macro-influencer. But who has like 5,000 or 10,000 followers, they are micro-influencers. They are very focused, less expensive, they have high engagement rate, authentic, and low barrier to entry. So again, our approach was we build a hashtag data set and micro-influencer data set. We classify political hashtag and user classification, and then we do the usual accuracy, precision, and recall and estimators. So this is the data set or technique. I'm not going into the details. That's how we have used for micro-influencer. We have used these following features: if the user is verified or not, if how many times he is retweeting, how many times he is getting liked, and what is the topic he is studying. And then we use a logistic regression to classify these micro-influencers. And again, for bots, we check that if there is a friend count is greater than 100,000 or follower count is less than 30. So these are the typical features for bots. So the final that I'm going to present is a push to trend. So as I said, that these days you can also rent a trend. Rent a trend means just like a rent a car, you can rent a trend. You can have your own, if you pay someone, you can trend. People can talk about you easily. How the people do that, that's I'm going to present next. So trend promoters are another Twitter users, but how they do that, they use multiple strategies. The first of the strategy is that they use bots, humans, they spam, they do fake trends, and then they have some coordinated groups, even they are verified accounts. Right? So for example, one of the example is that, just look at this, this is one of the influencers, one of the trend promoters, and said, okay guys, grab your keyboard and start trending boycott tomatoes, as we need to boycott tomatoes if we want to eat tomatoes. So this is just like a kind of, okay, let's have trended and then generate some public awareness, and then if the people are agreeing, so the prices will come down. So what are the attributes of trend promoters? They post large number of tweets containing the hashtag to create a trend. There are lots of duplicate tweets, and the trend promoter posts a high volume of tweets in a short amount of time. And their activity is abnormal in the beginning. That's how you detect them. So we develop a dataset prep for normal users and trend promoters from 8th November 2022 to 2021. And then we have 2061 promoters and 1839 normal users. So we use these features like tweet count, duplicate tweets, max n-gram, peak to mean ratio. So one of the important thing is that influencers have a peak rate in the beginning, and then they have nothing. The normal user have a almost variable low activity, so you can identify them with that activity as well. So we again use our hashtag, Anbar hashtag database, and then we remove the retweets from them, and we filter the tweets containing the original hashtags. And this is a data set. We got 2.9 million original tweets and 602 hashtags, and we 0.27 million users. And what we can see here is that the 15.7% of the promoters, 10 promoters, they post around 68% of the tweets. So these are the heavy hitters that we detect. Just like there's an example, Park News, they have 70% of the user labeled as 10 promoters. However, these are 99% of the tweets are done by just 15 users. So these 15 users, they were able to trend the whole hashtag. And this was a promotion score we use for getting the user classified into different categories. And that we use this score to identify that who is promoting at what time. So this is the system that we built. This is called a hash scope. What you can see in this system here is that we are observing the trending panel. What are the top 10 hashtags and what are these categories? So we have all these hashtag categories like campaign, entertainment, military. So we know at what time what is being discussed and who are the people who are behind those hashtags. What are the users? So our next effort is to build a graph of those people and then analyze those people if they are actually there are squads, what we call as there are coordinated efforts. So people are working as a team to create hashtags and to create some political maligning for each other. So this is the same thing just for the political category. We are observing all these hashtags are political. And we are extending this work for, we plan to extend this work for under the smart city, where the smart city concept is that you need some kind of a cyber surveillance as well, or a cyber surveillance, or what you can say is that a surveillance where the law and order situation is not created due to social media. Because in Britain there is one example where something happened at Twitter and that ended up in some riots. So there is one example, and there are some other examples where in US elections, so people said that the elections were won by using Twitter campaigns. So there are a lot of issues which are related from social media. So in summary, the alliance of social media and AI has enabled social computing for real-time examination of events. Considering the need of AI model for large-scale data sets, we developed Anbar, containing 1 of 6 billion tweets, and then we developed an epidemic surveillance system, which is enabling inexpensive and real-time monitoring, and we have a hash scope to determine Twitter trend for categories and user to detect bots, influencers, and trend promoters. So our developed data sets and tools are available on GitHub, and they're open source. You can use, or if you need any other information, you can contact me. So, okay. So these are the research publications that we did. Thank you very much. If you have any questions, so you're welcome.
Any questions?
Sure.
So this is really good research. With Twitter being taken over by the new boss, I heard that he's selling this status of being verified. I don't know, $10 or something. So that will be another challenge for the researchers now to verify whether somebody is verified or something.
Right. So actually, with the takeover of Musk, we have not only these challenges, we have multiple challenges. Right. So So one of the challenge is the verified stuff, that what was happening before and what was happening after. And the other thing is that he actually wanted to go after fake news and bots and others. But what happened is that with this business model, it amplified. So now people are actually impersonating as Elon Musk and then announcing something. So he really has some challenges. So and from the measurement point of view, I really would love to compare the pre-Musk area and post-Musk area, right? So that's really actually, and we really want to see that the changes he wanted to make with his vision, that how they are actually implemented and how people react to those changes. So we really have to see, and I would like to actually work on that.
So have you classified the types of social media that the people are using in Pakistan, and similarly what type of the information is basically disseminated on what type of social media platform? Maybe today is not used for every kind of information that we have. So maybe Facebook may have different TikTok may have different.
I mean, I would love to do that, but there are some challenges. I tell you what are those challenges. So the first challenge is that Twitter gives you an API to get data and analyze if you are a researcher. So if you can do some low-rate data, you can do that. But Facebook does not provide you an API to get data so that you can analyze. So then you have to go to the paid model and the other things. So that's one challenge. The second challenge is the PTA, which is actually the Pakistan Telecommunication Authority, they have the statistics that what kind of application are being used by consumer, but they don't know that what type of content is being used over those platforms. So for example, if something is going towards Facebook, they know, they can calculate, okay, how much bytes are going towards Facebook, just from the networking packets, just seeing as the networking packets. But they don't know that if people are watching or what type of content is being consumed on those platforms. They don't know. That is platform specific. And that is also not available because of privacy. We cannot do that. The Twitter model is different. Twitter model is there because people want to know other people's their thoughts. So that's why we are able to capture that. We started for the Facebook as well. We started for the Instagram as well. But in order to do that, either you have to be a friend of that person so that you can actually see, or either you have to be in that group if you want to observe that group. So these are both problematic and both challenging. You cannot do that. But yes, there is another way, workaround for that. What people do, a researcher in the social computing domain, what they do, they analyze the advertisements. So the platform itself shows you the advertisement that you like, right? So if I just observe the advertisement, I can know something about you. So let's say if you are searching about some book on the Google, so what will happen? You will see an ad of the same book on the Facebook. I tell you, you can do that. You search a book, you will see that ad on the Facebook. And if I somehow analyze just the advertising server, I know that what you're doing. That's how we can analyze. But that's again, there's a paid model that you get. But people have used the Facebook data to, one, check the number of immigrants in, let's say, GCC countries, that how people are migrating and where from X country to Y country, they have done that. And there are some other social issues that people have also observed using the Facebook advertisement data. Right. Any other question?
Thank you.
Thank you, Dr. Amir Mahmood, for sharing your research with us. For the next keynote talk on research on type pattern image classification, Dr. Liu Ying from Zhejiang University, Xi'an, China, will share her valuable research with us. Ms. Deng Liu, senior member IEEE, received a master's and PhD degrees in electromagnetics from Zhejiang University, Xi'an, China, in 2001 to 2004 respectively. Her research interests include prediction and control of antenna radar cross-sections and antenna theories and technology. She serves as the PPC co-chair for several IEEE flagship conferences. She She is a reviewer of several international journals.
Telecommunications, China. I'm very pleased to have this opportunity to share some of our research work with you. Thanks to the conference committee for giving me this opportunity. All right, now let's start. The title of my talk is Research on Tire Pattern Image Classification. Firstly, a brief introduction of myself. I'm the director of Center for Image and Information Processing, Xi'an University of Posts and Telecommunications, China. I obtained my PhD from Monash University, Australia, my master degree from National University of Singapore, my bachelor degree from Xi'an University, China. All right. In case you complain that there are no pictures of the presenter, here you are. This is a picture taken in late of this September, quite a recent one, right? Myself with my postgraduate students, some of them, we have more actually. This picture, myself with some of my research team members. They are all staff in our university. You can find me easily, right? Okay. Now let's start with the four following parts. I will share with you our work done in tire pattern image classification. Firstly, background of the research. According to the data from the Traffic Administration Bureau of the Ministry of Public Security, China had nearly 400 million motor vehicles by the end of last year. Here are statistics about traffic accidents and the loss of life cost, injuries, and property loss. Similarly, in Pakistan, with the increasing number of vehicles available, there are more traffic accidents, which cause loss of precious lives and damage of personal property, etc. While in traffic accident management and solving of relevant criminal cases, tire patterns provide important clues to help the police in tracing the suspected vehicles. Nowadays, tire pattern analysis in practical scenario is mainly implemented manually. Hence, there is an urgent need to design efficient and automatic or semi-automatic tire pattern recognition systems. Such systems system rely on image classification techniques. Alright, we can see that the research on tire pattern image classification, in short TPIC, is of great value not only because of the practical needs, but also in terms of theoretical research on fine-grained image classification. Fine-grained because tire pattern images are fine-grained images. Okay. Our research center was established in the year 2011. And we have a joint lab with the Public Security Department of Shanxi Province. The team focused on image and video processing with applications in public security field. The picture on the left includes most of our team members. The picture on the right includes some of our team members and some police staff in the joint lab. The police staff actually provide us useful information in application domain and also help us in obtaining useful testing data. Alright, second part, I will introduce you the self-built dataset. The dataset CIIP TPID. CIIP is a research center, and TPID refers to tire pattern image data. This dataset includes over 11,000 images, and it has not only tire surface patterns but also tire indentation marks. The collection of such data is not easy. It took us over 4 years to build this dataset with the effort of our postgraduate students. The tire indentation marks are on different carriers such as soil, sand, mud, etc. This is the largest tire pattern image dataset available for academic use, and it has been used by many domestic and foreign research teams. In addition, this dataset has been selected as a testing dataset at Multimedia Grand Challenge in international conferences, including ACM Multimedia Asia, ICME 2021, BCIP 2022. These are pictures taken on the spot as a grand challenge. The first one, myself hosting the grand challenge at ACM Multimedia Asia. This is a conference mainly with participants from Asia in multimedia processing domain. The second picture, myself with our technical staff on organizing the online session at ICME 2021. The third picture shows the presentation from the first winner. The picture at the bottom include the winners, winning teams. The guy in the middle is the first prize winner, the team leader of the first prize winning team. Okay. Now the third part, I will share with you some of our research done in tire pattern image classification. We have to admit that there is limited amount of work done in this field because there are a fewer number of researchers in this area, and there is a lack of standard data set. Our data set is open to the public in the year 2019. Was open to the public in that year. The development of techniques in PPIC mainly has these three stages. In early stage, researchers focus on extracting low-level texture features from tire pattern images. The obtained features were then sent into image classifiers such as support vector machine for classification purpose. More recently, convolutional neural networks were used to enhance the performance. Well, a potential future research trend is few-shot learning. We will explain this later. Alright, firstly, a texture feature descriptor we proposed named HawkDG. Hawk is referring to histogram of oriented gradient. DG means dominant gradient. HawkDG is found to be robust not only to illumination and scale changes, but also it is rotation invariant. Experimental results prove the effectiveness of HawkDG. It provides performance close to that of CNN, and it performs other traditional text features. Let's see Hawk descriptor. Firstly, the magnitude and direction of gradient are extracted from each pixel in the image. To construct Hawk descriptor, the entire image is divided into cells of size 8 by 8. From each cell, a feature vector of length 9 is obtained. We won't go to the details of the calculation, as you can find that easily. the global feature vector, we observed that there is a dominant gradient here, which is the dominant component with maximum gradient magnitude. Dominant gradient is robust to rotation, illumination, and scale changes. Using this dominant gradient, we can align the cell feature vectors. These are tile pattern images with different shooting angles. Red arrows show the dominant gradient we obtained. Using these equations we designed, we can align all the cell feature vectors based on the dominant gradient. In this way, the feature vector obtained will be rotation invariant. All right. We normalize the aligned cell feature vector and then concatenate the vector from all the cells to get the final HOC-DG feature. All right. Okay, again, SVM classifier is used for classification purpose. In our experiments, we compare the performance of the proposed HOC-DG with HOC and other traditional text features as well as CNN. It is observed that HOC-DG provides performance as close as that of CNN, and it outperforms other traditional text features. It is quite amazing that in such case, the performance of HOC-DG is nearly slightly higher than CNN. This doesn't mean that HOC-DG is always better than CNN for other tasks as well. But it shows that HOC-DG is quite an efficient descriptor for tire pattern images. All right, in summary, by defining circular cells, which is used to align the cell vector features, the HOC-DG feature is made to be robust to rotation environment, to rotation changes. Yeah, because we designed a way to align each cell feature vector based on the dominant direction. Okay. Next, we have proposed a way to perform tire pattern image classification based on transfer learning. We know that tire pattern images are not easy to collect, and there are not large amount of samples available. Hence, we make use of the transfer learning concept here. Firstly, a pre-trained model using large image dataset such as ImageNet is obtained, and then it is fine-tuned using tire pattern images to obtain a new model. With this new model, we combine image feature from different fully connected layers to form the final tire pattern image feature. Then, using this feature for SVM classification. Experimental results prove the effectiveness of the proposed method. The framework of the method: firstly, a pre-trained model, and then fine-tuned based on transfer learning, a new CNN model obtained, different layers features from different layers are combined. And then PCA is conducted for dimension reduction. Thus, we obtain the so-called transfer learning feature, TLF, which is sent to SVM classifier. All right. Tested on type pattern image dataset, we find that TLF, the proposed method, is effective compared with other texture features. We also compare the way of using multiple layers features, combining different layers, compared with using single layers only. Surely, it is proved that fusing features from different layers, we can get better performance in terms of classification accuracy. All right. In summary, transfer learning fine-tuning is a useful way for image classification with limited amount of sample data. All right. Okay, next, few-shot learning. We know that deep learning, convolutional neural network, the outstanding performance of CNN relies on large amount of training data. When we have not enough training data available, there will be a overfitting problem. Few-shot learning is designed for deep learning with small amount of training data. Okay. Graph convolutional neural network, GCN, is a type of few-shot learning technique. Based on GCN, we propose an improved version. This method we proposed use cross-attention mechanism to select salient region features. That is, important features of the original image are extracted, which is used as the initial node feature of the graph. In this way, we enhance the performance of the graph convolutional network. Experimental results prove the performance of the proposed method, which is effective. All right. The proposed method is named in short as GCN-NFO. GCN refers to graph convolutional network, and NFO as node feature optimization. The method contains 3 modules: embedding module, cross-attention module, graph convolutional module. In the embedding module, the initial feature is obtained using some convolutional blocks. In the cross-attention module, the important image feature are obtained or extracted from the support set and the query set. We will not go to the details of the equations here. Anyway, step 2, this module will obtain important features, which is used in step 3 as the initial node feature of the graph. All right. Okay. The graph itself iteratively will spread and adjust the structure itself. And in this way, by optimizing the initial node feature, we enhance the performance of the graph. All right. The proposed method is tested over different data sets with different contents. Supervised learning tasks over different data set. Also with semi-supervised learning tasks. All these results proves the effectiveness of the proposed method. All right. In summary, using cross-attention mechanism to obtain the more silent features. In this way, we optimize the initial node feature of the graph. Yeah. By optimizing the initial node feature of the graph structure itself has a so-called message passing mechanism. In this way, the performance of GCN can be enhanced for few-shot image classification task. All right. Just now we have explained some of our work done in tire pattern image classification, including texture feature descriptor we proposed, including transfer learning based texture tire pattern image classification and few-shot learning. Now let's come to the last part, conclusion. In conclusion, we can see that tire pattern image classification is important as it can provide useful clues for police in traffic accident management and relevant case solving. And in this talk, I have shared some of our research work done in this field. Surely in our research team, we have researched not only on tire pattern but other types of images and videos, and other image video analysis tasks such as event detection, scenario construction, as well as video retrieval. Alright, if you are interested in any of these topics, you're always welcome to contact us. Okay, now here for future contact, here I provide our email address for you. And you're really welcome to visit us in Xi'an. Sorry.
She couldn't connect with us for the question and answers due to some internet restrictions. She will welcome all of your queries over her email. Thank you. Now I would like to invite Dr. Bakar to come here and to present the shields to our respectable guests. Please give him a round of applause. Now I would like to invite Dr. Zulkarn and Gilani, please come and receive the shield. Now I request Dr. Amir Beg to please come here and
Hello. Good afternoon, everyone. I'm Ying Liu from Xi'an University of Posts and Telecommunications, China. I'm very pleased to have this opportunity.
Please come here and share his views with us. Thank you so much.
Okay, so I have few announcements to make. First of all, I apologize for the quality of sound quality because right now in China there are some COVID restrictions, and due to that the speaker could not come to the campus for the live talk. We apologize for that part. So we have now break. The next session will start at 2:30 p.m. And right now it's a lunch and prayer break. For lunch for the invited speaker and distinguished guests, we have arranged in 2. So volunteers will take to that room. And now we have a break for 1 hour. And we will meet at 2:30 p.m. Thank you.
I hope this session was engaging for all of you. I want to offer my thanks to the session co-chair, Professor Dr. Ghalib Asadullah, Dr. Bakar, and all the presenters, the audience. With this, I officially announce the closing of the session. Thank you so much.
Here you are. This is a picture taking.
Bismillahirrahmanirrahim. Open source systems and technologies have played a vital role in the development of technology.
Hello.
Institute of Computer Science, in cooperation with IEEE, is hosting 16th International Conference on Open Source Systems and Technologies, ICOS 2022. The main theme of ICOS 2022 is Web 3.0 that leverages machine learning, artificial intelligence, and blockchain technologies. Web 3.0 has enabled NFTs, cryptocurrencies, and blockchain and metaverse. The core of Web 3.0 is open source tools which are focused at this conference. ICOS 2022 has invited distinguished national and international speakers. These speakers will share cutting-edge research from their domains of artificial intelligence, cybersecurity, computer vision, big data, robotics, and emerging technologies. In addition, national and international speakers will present high-quality research papers in the paper track. We have also arranged Brainiac competition where students' team will participate in hackathons related to IoT, artificial intelligence, graphic designing, and search engine optimization. I would like to encourage students and faculty members to participate in the conference in the lively city of Lahore and become part of the open source community. Bismillahirrahmanirrahim. Open source systems and technologies have played a vital role in the development of technologies and rapid innovation cycles. This year, Al-Khwarizmi Institute of Computer Science, in cooperation with IEEE, is hosting 16th International Conference on Open Source Systems and Technologies, ICOS 2022. The main theme of ICOS 2022 is Web 3.0 that leverages machine learning, artificial intelligence, and blockchain technologies. Web 3.0 has enabled NFTs, cryptocurrencies, and blockchain and metaverse. The core of Web 3.0 is open source tools which are focused at this conference. ICOS 2022 has invited distinguished national and international speakers. Bismillahirrahmanirrahim. Open source systems and technologies have played a vital role in the development of technology and rapid innovation cycles. This year, Al-Khwarizmi Institute of Computer Science, in cooperation with IEEE, is hosting 16th
Established in August 2002 with an intention of conducting research and development activities in the areas of information technology and computer science. Established in August 2002 with an intention of conducting research and development activities in the areas of information technology and computer science. Al-Khwarizmi Institute of Computer Science, KICS, today stands along with the advanced technology centers of the country. According to the Joint Survey of Knowledge platform Singapore and British Council, KICS was highlighted as the pioneer initiative among the research organizations in Pakistan. The institute is geared up to provide the country with trained resources and research staff for development of high-tech products and services, to exercise commercialization through incubation of high-tech companies, and to promote R&D culture in the country through technology innovation and industrial collaborations. Established in August 2002 with an intention of conducting research and development activities in the areas of information technology and computer science. Al-Khwarizmi Institute of Computer Science, KICS, today stands along with the advanced technology centers of the country. According to the Joint Survey of Knowledge platform Singapore and British Council, KICS was highlighted as the pioneer initiative among the research organizations in Pakistan. The institute is geared up to provide the country with trained resources and research staff for development of high-tech products and services, to exercise commercialization through incubation of high-tech companies, and to promote R&D culture in the country through technology innovation and industrial collaborations. More than 250 individuals, including PhDs, MPhils, master degrees, and administrative staff, are well focused and passionate about their jobs. Currently, 26 labs are operating at the institute, which are working on various research areas including artificial intelligence, communication technologies, software development, power systems, industrial automation, language engineering, technology incubation, and media studies.
Khwarizmi Institute of Computer Science has provided a platform in the education sector in Pakistan, where we have developed solutions not only for the industrial sector in our nation, but also for the private sector and the public sector.
More than 100 projects funded by local and international entities so far have been successfully completed. Notable projects that are being worked on presently at KICS include Urdu search engine, brain informatics, classification and modeling of brain data, establishment of National Center for Cybersecurity, National Center for Robotics and Automation, National Center for Artificial Intelligence, development for water pump agricultural tubewell, energy efficiency measurement and improvement, automatic Pakistani postal address recognition and parcel routing, energy extraction by safe disposal of municipal waste using nanotechnology, virtual reality-based neurogaming for mindfulness in children and ADHD patients, and to name a few. Apart from the research work, KEX runs a testing facility for international tests like Cisco, Microsoft, GMAT, and Oracle. It also offers professional trainings. KEX has signed agreements and MOUs with more than 100 national and international research and academic organizations and industry for mutual R&D collaborations. For more details, please visit our website www.kex.edu.pk or feel free to contact us. Established in August 2002 with an intention of conducting research and development activities in the areas of information technology and computer science, Al-Khwarizmi Institute of Computer Science (KEX) today stands along with the advanced technology centers of the country. According to the Joint Survey of Knowledge Platform Singapore and British Council, KEX was highlighted as the pioneer initiative among the research organizations in Pakistan. The institute is geared up to provide the country with trained resources and research staff for development of high-tech products and services, to exercise commercialization through incubation of high-tech companies, and to promote R&D culture in the country through technology innovation and industrial collaborations. More than 250 individuals, including PhDs, MPhils, master degrees, and administrative staff, are well-focused and passionate about their jobs. Currently, 26 labs are operating at the institute, which are working on various research areas including artificial intelligence, communication technologies, software development, power systems, industrial automation, language engineering, technology incubation, and media studies.
Khwarizmi Institute of Computer Science has provided a platform in the education sector in Pakistan, where we have developed solutions not only for the industrial sector in our nation, but also for the private sector and the public sector.
More than 100 projects funded by local and international entities so far have been successfully completed. Notable projects that are being worked on presently at KEX include Urdu Search Engine, Brain Informatics, Classification and Modeling of Brain Data, establishment of National Center for Cyber Security, National Center for Robotics and Automation, National Center for Artificial Intelligence, development for water pump agricultural tube well, energy efficiency measurement and improvement, automatic Pakistani postal address recognition and parcel routing, energy extraction by safe disposal of municipal waste using nanotechnology, virtual reality-based neurogaming for mindfulness in children and ADHD patients, and to name a few. Apart from the research work, KEX runs a testing facility for international tests like Cisco, Microsoft, GMAT, and Oracle. It also offers professional trainings. KEX has signed agreements and MOUs with more than 100 national and international research and academic organizations and industry for mutual R&D collaborations. For more details, please visit our website www.kex.edu.pk or feel free to contact us. Established in August 2002 with an intention of conducting research and development activities in the areas of information technology and computer science, Al-Khwarizmi Institute of Computer Science (KEX) today stands along with the advanced technology centers of the country. According to the Joint Survey of Knowledge Platform Singapore and British Council, KEX was highlighted as the pioneer initiative among the research organizations in Pakistan. The institute is geared up to provide the country with trained resources and research staff for development of high-tech products and services, to exercise commercialization through incubation of high-tech companies, and to promote R&D culture in the country through technology innovation and industrial collaborations. More than 250 individuals, including PhDs, MPhils, master degrees, and administrative staff, are well-focused and passionate about their jobs. Currently, 26 labs are operating at the institute, which are working on various research areas including artificial intelligence, communication technologies, software development, power systems, industrial automation, language engineering, technology incubation, and media studies.
Khwarizmi Institute of Computer Science has provided a platform in the education sector in Pakistan, where we have developed solutions not only for the industrial sector in our nation, but also for the private sector and public sector.
More than 100 projects funded by local and international entities so far have been successfully completed. Notable projects that are being worked on presently at KICS include Urdu Search Engine, Brain Informatics, Classification and Modeling of Brain Data, Establishment of National Center for Cybersecurity, National Center for Robotics and Automation, National Center for Artificial Intelligence, Development for Water Pump Agricultural Tubewell, Energy Efficiency Measurement and Improvement, Automatic Pakistani Postal Address Recognition and Parcel Routing, Energy Extraction by Safe Disposal of Municipal Waste using Nanotechnology, Virtual Reality-Based Neurogaming for Mindfulness in Children and ADHD patients, and to name a few. Apart from the research work, KICS runs a testing facility for international tests like Cisco, Microsoft, GMAT, and Oracle. It also offers professional trainings. KICS has signed agreements and MOUs with more than 100 national and international research and academic organizations and industry for mutual R&D collaborations. For more details, please visit our website www.kics.edu.pk or feel free to contact us. Established in August 2002, with an intention of conducting research and development activities in the areas of information technology and computer science, Al-Khwarizmi Institute of Computer Science, KICS, today stands along with the advanced technology centers of the country. According to the Joint Survey of Knowledge Platform Singapore and British Council, KICS was highlighted as the pioneer initiative among the research organizations in Pakistan. The institute is geared up to provide the country with trained resources and research staff for development of high-tech products and services, to exercise commercialization through incubation of high-tech companies, and to promote R&D culture in the country through technology innovation and industrial collaborations. More than 250 individuals, including PhDs, MPhils, master degrees, and administrative staff, are well focused and passionate about their jobs. Currently, 26 labs are operating at the institute, which are working on various research areas including artificial intelligence, communication technologies, software development, power systems, industrial automation, language engineering, technology incubation, and media studies.
Khwarizmi Institute of Computer Science has provided a platform in the education sector in Pakistan, where we have developed solutions not only for the industrial sector in our nation, but also for the private sector and public sector.
More than 100 projects funded by local and international entities so far have been successfully completed. Notable projects that are being worked on presently at KICS include Urdu Search Engine, Brain Informatics, Classification and Modeling of Brain Data, Establishment of National Center for Cybersecurity, National Center for Robotics and Automation, National Center for Artificial Intelligence, Development for Water Pump Agricultural Tubewell, Energy Efficiency Measurement and Improvement, Automatic Pakistani Postal Address Recognition and Parcel Routing, Energy Extraction by Safe Disposal of Municipal Waste using Nanotechnology, Virtual Reality-Based Neurogaming for Mindfulness in Children and ADHD patients, and to name a few. Apart from the research work, KICS runs a testing facility for international tests like Cisco, Microsoft, GMAT, and Oracle. It also offers professional trainings. KICS has signed agreements and MOUs with more than 100 national and international research and academic organizations and industry for mutual R&D collaborations. For more details, please visit our website www.kics.edu.pk or feel free to contact us. Established in August 2002, with an intention of conducting research and development activities in the areas of information technology and computer science, Al Al-Khwarizmi Institute of Computer Science, KICS, today stands along with the advanced technology centers of the country. According to the Joint Survey of Knowledge Platform Singapore and British Council, KICS was highlighted as the pioneer initiative among the research organizations in Pakistan. The institute is geared up to provide the country with trained resources and research staff for development of high-tech products and services, to exercise commercialization through incubation of high-tech companies, and to promote R&D culture in the country through technology innovation and industrial collaborations. More than 250 individuals, including PhDs, MPhils, master degrees, and administrative staff, are well focused and passionate about their jobs. Currently, 26 labs are operating at the institute, which are working on various research areas including artificial intelligence, communication technologies, software development, power systems, industrial automation, language engineering, technology incubation, and media studies.
Al-Khwarizmi Institute of Computer Science has provided a platform in the education sector in Pakistan, where we have developed solutions not only for the industrial sector in our nation, but also for the private sector and the public sector.
More than 100 projects funded by local and international entities so far have been successfully completed. Notable projects that are being worked on presently at KICS include Urdu Search Engine, Brain Informatics, Classification and Modeling of Brain Data, Establishment of National Center for Cybersecurity, National Center for Robotics and Automation, National Center for Artificial Intelligence, Development for Water Pump Agricultural Tubewell, Energy Efficiency Measurement and Improvement, Automatic Pakistani Postal Address Recognition and Parcel Routing, Energy Extraction by Safe Disposal of Municipal Waste using Nanotechnology, Virtual Reality-Based Neurogaming for Mindfulness in Children and ADHD patients, and to name a few. Apart from the research work, KICS runs a testing facility for international tests like Cisco, Microsoft, GMAT, and Oracle. It also offers professional trainings. KICS has signed agreements and MOUs with more than 100 national and international research and academic organizations and industry for mutual R&D collaborations. For more details, please visit our website www.kics.edu.pk or feel free to contact us. Established in August 2002, with an intention of conducting research and development activities in the areas of information technology and computer science, Al-Khwarizmi Institute of Computer Science, KICS, today stands along with the advanced technology centers of the country. According to the Joint Survey of Knowledge Platform Singapore and British Council, KICS was highlighted as the pioneer initiative among the research organizations in Pakistan. The institute is geared up to provide the country with trained resources and research staff for development of high-tech products and services, to exercise commercialization through incubation of high-tech.
Bismillahirrahmanirrahim. The development of technologies and rapid innovation cycles. This year, Al-Khwarizmi Institute of Computer Science, in cooperation with IEEE, is hosting 16th International Conference on Open Source Systems and Technologies, ICOS 2022. The main theme of ICOS 2022 is Web 3.0, that leverages machine learning, artificial intelligence, and blockchain technologies. Web 3.0 has enabled NFTs, cryptocurrencies, and blockchain and metaverse. The core of Web 3.0 is open source tools, which are focused at this conference. ICOS 2022 has invited distinguished national and international speakers. These speakers will share cutting-edge research from their domains of artificial intelligence, cybersecurity, computer vision, big data, robotics, and emerging technologies. In addition, national and international speakers will present high-quality research papers in the paper track. We have also arranged Brainiac competition, where students' team will participate in hackathons related to IoT, artificial intelligence, graphic designing, and search engine optimization. I would like to encourage students and faculty members to participate in the conference in the lively city of Lahore and become part of the open source community. Bismillahirrahmanirrahim. Open source systems and technologies have played a vital role in the development of technologies and rapid innovation cycles. This year, Al-Khwarizmi Institute of Computer Science, in cooperation with IEEE, is hosting 16th International Conference on Open Source Systems and Technologies, ICOS 2022. The main theme of ICOS 2022 is Web 3.0 that leverages machine learning, artificial intelligence, and blockchain technologies. Web 3.0 has enabled
Established in August 2002 with an intention of conducting research and development activities in the areas of information technology and computer science, Al-Khwarizmi Institute of Computer Science, KICS, today stands along with the advanced technology centers of the country. According to the Joint Survey of Knowledge Platform Singapore and British Council, KICS was highlighted as the pioneer initiative among the research organizations in Pakistan. The institute is geared up to provide the country with trained resources and research staff for development of high-tech products and services, to exercise commercialization through incubation of high-tech companies, and to promote R&D culture in the country through technology innovation and industrial collaborations. More than 250 individuals, including PhDs, MPhils, master degrees, and administrative staff, are well focused and passionate about their jobs. Currently, 26 labs are operating at the institute, which are working on various research areas including artificial intelligence, communication technologies, software development, power systems, industrial automation, language engineering, technology incubation, and media studies.
Khwarizmi Institute of Computer Science has provided a platform in the education sector in Pakistan, where we have developed solutions not only for the industrial sector in our nation, but also for the private sector and the public sector.
More than 100 projects funded by local and international entities so far have been successfully completed. Notable projects that are being worked on presently at KICS include Urdu search engine, brain informatics, classification and modeling of brain data, establishment of National Center for Cybersecurity, National Center for Robotics and Automation, National Center for Artificial Intelligence, development for water pump agricultural tube well, energy efficiency measurement and improvement, automatic Pakistani postal address recognition and parcel routing, energy extraction by safe disposal of municipal waste using nanotechnology, virtual reality-based neurogame.
Higher Education Commission for the years 2012 to 2013. Please welcome Dr. Muhammad Haroon Yusuf with big round of applause.
Assalamu alaikum everyone. First of all, it's really an honor to be here as an invited speaker. Today, I will be sharing our work in the domain of swarm robotics and particularly AI on the edge. So, this is the outline of my presentation. For students, I will be a bit more simple and easy to go, so that I'm not going to in detail, or we can say too much technical details of algorithms and so many things. So overall introduction and scope, then what are the application areas where we can use these robot swarms, and then we will see different experimentations related to swarm intelligence algorithms, not only in the simulation as well as on different hardware platforms. And finally, I will conclude my talk with computer vision and AI on the edge applications. So, starting with the introduction related to swarm robotics. So actually, when we talk about swarm, so here we are not talking about a single robotic agent. We are talking about multiple different robotic agents, but again, in some formation control mechanism to have some sort of collective behavior. Like if we look at different species around us, like how different birds are moving, similarly ants and other these kind of species, so they are doing many tasks in their collaborative behavior by using their own essence, logic, intelligence with very simple rules. Like here we can see an example where a termite mound is built by centimeter scale different insects, and the termite mound they build, it is actually around 10-30 meters long. So this is how that collective activity resulted in achievement of something big. Similarly, if we talk about the same behaviors in robot swarms, so actually in robot swarms we are going to couple these biological inspired intelligence algorithms with robotic agents. So ultimately these robotic agents are going to be capable enough or intelligent enough so that they can achieve a collaborative task, they can achieve a particular goal they have been assigned. But when we talk about how we can see these robot swarms, how many different agents would be there, what are the different capabilities or basic characteristics of these swarms would be there. So generally we can see in a robot swarm, usually it's mandatory to have at least 3 different nodes. So if the swarm of 2 robotic agents is not considered as a swarm, so generally the 3 robotic agents should be there. Then there should be limited human control. We can't even have a totally autonomous behavior because to some extent they can even ruin everything. So the limited human control should be there in these robot swarms. And obviously the cooperation is the key. The cooperative behavior, that is the key. If we talk about different behaviors of these robot swarms, so generally the behaviors are categorized into aggregation, flocking, foraging, navigation, path formation and task allocation, where sometimes these robotic agents are looking for a particular task, for searching something interest, similarly maybe moving towards a particular goal in a formation-like pattern. So there can be any different tasks like out of these which we can consider as a behavior of robot swarms. If we talk about the scope, like this is basically a scope on which we are actually working on, but talking about in general, swarm robotics is much beyond this. Like we are actually working to have different R&D solutions scalable on different platforms, UAVs, UGVs, as well as AUVs, or we can say ROVs. And the key domains on which we were actually working are swarm intelligence, decentralized communication, and computer vision and AI. So actually, the first two domains, swarm intelligence and decentralized communication, they were actually there to have a collaborative intelligence behavior that we have to impart and deploy on both agents. And from application side, we are actually working in the domain of computer vision and AI, so that we can get some benefit out of those robotic agents to achieve a certain goal. The application areas which we were targeting, it was particularly the defense sector, because looking at the modern warfare, so many countries are nowadays working in UAV swarms. So the defense sector, then video surveillance and monitoring, scene understanding, and particularly one of the challenges that Pakistan is right now facing, that is the disaster management. How we can get a real-time picture, how we can establish a quick emergency system. So these are the areas in which actually we are working on. And similarly, to deploy these algorithms, we are also working in indigenous development of different robots like miniature robots, UGVs, and UAVs. So these are the different application areas like area surveillance, where we can have anomaly detection, border surveillance, crowd analysis, and object recognition. For disaster management, we can have a quick real-time feedback about flood-affected areas, wildlife fire, search and rescue missions can be planned, area exploration can be done by using these robot swarms. And academically, we can have different new kind of mobile robots. We can transform these multi-unit systems into a robot swarm. So for students, I would like to just give a big picture like how a particular task can be accomplished by robot swarms. Like here we can see there are two set of incidents happening in this picture. One is basically a fire incident, and other one is actually a person having a pistol in hand. So actually we can say there are two anomalies. So how this whole process is actually working on, for example, if we are having some area service units, obviously that complete force is going to navigate over the area, explore the area, and ultimately finding one activity. Like for example, there are few nodes who are basically targeting the fire incident, and similarly another sub-swarm is generated, connected with the main ground control station as well, and that sub-swarm is going to deal with the other anomaly. So this is just an idea how we can have different robotic agents achieving a certain task or goal in a formation or more intelligent pattern. So coming towards all these different domains, I will start giving some examples about the algorithms. So we initially started with simulation of different algorithms. The first one is basically a decentralized pattern formation and navigation approach for swarms, a multi-UAV approach, in which actually we were having different UAVs which are placed in a clustered environment with obstacles. All these UAVs are actually searching other close UAVs by using neighbor search algorithm, and then we have a basically train talent map is also there. That we have using Opera map. And finally the RLT algorithm, the rapid exploration of algorithm, generates a clear feed path for individual UAV navigation. And finally multiple algorithm was used for the localization, and ultimately all the mobile robots which are built in dispersed manner. So after execution, they are finally aggregated towards a particular point. So this was the first algorithm we tested in a simulation platform, Gazebo. Then we move on, and this was basically a multi-platform hardware in the drone simulation for decentralized swarm communication, where we actually emulated our different nodes by using hardware in the drone testing. And here we use micro-arc water, which are basically acting as an individual UAV, and both are basically connected to a ground control station. And finally, these emulated individual UAVs are performing a communication task for the set purpose. Lastly, we experimented in comparison, that is sub-swarm generation. Again, the simulation indicates there are 11 different nodes, and here they suddenly identify one anomaly of 5 random incidents there, and ultimately the rest of the nodes are moving towards the next target. But this particular node established a team connectivity, because when we talk about the sub-swarm generation, so in sub-swarms there are different swarms are in existence, and how we are going to connect them to the central ground control station. So obviously there is a relay node that is involved, that is basically establishing. So this was a simulation in comparison and ultimately giving the model. Then comes to us how we are going to use these algorithms, where we are going to deploy these algorithms. So we develop different platforms. Few of us developed indigenously, and similarly few are basically being used off the shelf. So for example, this is one of our projects as well, named as SimBot, a miniature bot that we developed in our lab. And this SimBot is actually intelligent enough. We are having 3 different variants of this miniature robot. One is basically a base tuner, then the other one is also having an onboard computing source, and the third one is also having a camera along with the accelerator. So these agents, like here you can see, they are basically running a SLAM algorithm, and they are actually simultaneously localizing and mapping the environment. So this was also being sent to an international competition as well. So this also won the competition locally here. Similarly, we also participated like TechCon. We have been the finalist of OpenCP competition, and similarly the robotic startup type of NCRA. So this work was basically presented not only this miniature robot, but also the algorithm deployed on this robot. The next part we have an indigenous development again, and collaboration with one of the industry. This is basically named as Black Hawk. This is a UAV that we had used in our experimentation, equipped with Jetson Xavier, along with the communication module modem. Then for supervisors, we have XMR, we have another computer source here, the Spirit 5. Then comes to the camera. There are dual cameras here. One is a little camera, the other one is a stereo camera. And for localization, we have the GPS tree, and finally autopilot quiz on or tube is there. So this is basically another platform for the testing of different form of algorithms. Then before deploying our algorithm directly on the UAVs, we also use a UAV as well, because directly deploying algorithms on UAVs, it's very difficult and again risky as well. Because one of the UAVs is even very costly due to the different in it, and we use the UAVs for this purpose as well. And again, the UAVs are also going to have a similar kind of equipment there, because we just want to make the uniform platform. This is the UAV we use Arduino, this is the US product. Also have the orange tube hawk, then GPS tree, again the same camera, Jetson Nano, Jetson Xavier, both of them, plus one more thing that is basically LiDAR, RT LiDAR, which was used. So these are the 3 different platforms we used for experimentation purpose. Now coming towards the experimentation. Like here, you can see the first experiment, that is basically UAV swarm, having 3 UAVs. It's a homogeneous swarm because only UAVs are there. Its formation control is there, and force computing is done on board, because as we say, all these units are equipped with computer source. Jetson board is there, so whole algorithm is basically being run on the UAVs, and it's a leaderless form. None of these nodes are going to act as a leader. So this was the first experiment we performed just to maintain the formation control. Then we move on towards the leader-follower formation. And for that, before going towards direct implementation of the UAVs, we initially tested the algorithm on the UGVs, where this particular node is acting as a leader. So this is a homogeneous 4 UGV swarm with follow control is there, and rest of 3 UGVs are following the leader here. So they are basically taking a certain mission. As the leader is proceeding, the follower is going to follow that particular leader. Then this is just a homogeneous leader-follower swarm. Then coming towards the heterogeneous leader follower swarm, where we are having couple of UAVs and 3 UAVs there. So this is basically 2 UAVs and 3 UAVs heterogeneous swarm in decentralized leader follower formation, and it's completely autonomous mission, indicating the following area of the swarm. So here we can see this one is the leader. All other UAVs, this is the second UAV, 3 UAVs are there, so they are following this UAV. At one instance, they were also tested what in case the leader is failed. Like here you can see the battery is drained, so leader is no more. So automatically we have set a priority, the other UAV is going to become the leader now. So now this UAV is going to act as a leader, and UAVs are going to follow that leader. Again, as the leader moves, so UAVs are going to follow that. Then comes a heterogeneous swarm. Again, in leaderless formation, where we can see 3 UAVs and 5 UAVs are there. Out of these 5 UAVs, we use 3 UAVs in this experimentation. So the whole demonstration can be seen here, right? 3 UAVs are there. Then we can see the UAVs also in movement. So again, decentralized heterogeneous swarm, completely autonomous mission is there, and again the whole computing is being done under robotic events. Nothing is being done at the server side, or you can say the ground control station. So actually the whole computing is being done on the UAV as well as the UAVs, because both are equipped with the onboard computing resource. So as the formation is followed, similar to the UAVs also mimicking the same behavior. So this was all about different swarm intelligence algorithms. Now coming towards the application side, like how we can use these robot swarms to achieve something. So just to demonstrate a particular example here, we can have an example that is a target detection and rescue. So for example, in this experimentation, so here we set a particular target, like this car is a target, and all 3 UAVs are now moving towards the target. They are basically searching the area, they are exploring the area, and within the area they are searching for the target. And for the time being we have set the target, this car. Clear? So once a particular UAV detected that target, so all other UAVs and UAVs are going to rescue that particular target. So we just want to have an application of just making the behavior that we may require in different search and rescue missions in real world, where we can see some target, maybe some person who is maybe needing some help in case of, like the medical help may be required, sometimes food is required, sometimes life jackets may be required. So what we can do, we can have different UAV swarms which are basically exploring the area where they can find a certain region of interest, person of interest, object of interest, so they can ultimately send the information back to the ground control station, and ground control station send other nodes to provide different rescue opportunities. For example, in this case, this was just a mission, just indication how we are going to achieve it. At next stage, what we are doing, we are also going to have a couple of drones which can carry load. So we are going to have some sort of search and rescue mission, like where a person may be needing help, and we can provide that help to that person by dropping medical aid, the food, and anything like this one up to a 5 kg weight in that particular. Similarly, we are also trying to establish emergency communication system by using different approaches so that they can connect towards some quick response force. Because whenever there is a disaster, so generally the very first thing that demolished, that is basically the communication and overall physical infrastructure. So we are going to use these robot swarms in these kind of situations. I also want to give you a few glimpses of AUV as well. We haven't tested this one for the swarming purpose, but we just are trying to have some initial experiments on this very remote as well. So all of these experiments which we can see here, they are basically showing how different robot swarms can achieve a certain goal. So if we just again look at this particular heterogeneous swarm, so we can use these heterogeneous swarms in different civil application areas as well. For example, the areas where we are going to have some missions, like sometimes in our country we are dealing with different kind of procession, the gathering. So our law enforcement agencies, they are needing these kind of solutions where they can have aerial surveillance, where they can maybe look at number of persons, what is the behavior going on there, and then similarly how much area is being closed or affected. So all this we can do by using these aerial robot swarms. Now coming towards the application domain, again we have used the similar equipment again, the same UAVs there. So for that purpose we have developed this one of the platform named as OBDAP, Onboard Data Acquisition and Processing Platform. Why we consider the platform? Because it's basically going to process the real-time feeds on board. So we have tested different algorithms on our UAVs. So for example, this is the first experiment we performed for aerial object detection. So we tested the algorithm. This is basically a video where people coming over the nose from UAV, Tesla nose, similarly people moving within the campus. So the whole computing is being done on the aerial unit. So algorithm is not only tested on the server side but also deployed by using NVIDIA Jetson weighted board. So our UAVs are equipped enough to process the real-time data. Similarly, the next demo, that is basically the crowd estimation and crowd analysis we can say. So this video basically a dataset video, and this one is basically the people coming over the mosque, and we are simply calculating the estimate how many persons are coming. And now we are extending this work where we can simply see what is the behavior of the crowd. So how the crowd is going to act, are they in cool and calm mode, are they in agitated mode. So this is going to help the law enforcement agencies to deal with the situation. Another issue that world is facing right now and the last few years, we have seen so many incidents of the forest fire. So again, the same UAV swarms are going to use to detect the fire incidents within the urban as well as the forest areas. So we can simply get an estimation about first the detection, then the estimation, and even we can extend towards what will be the flow, how much this fire is going to affect, and what are the next areas that are going to be affected. Similarly, we can even use UAVs, a bit large scale UAVs again, that can carry different balls, fire safety balls, and we can throw those balls to those areas so that we can stop spreading the fire. Then this is just again demonstration of object detection and tracking by UAVs. Again, the whole board computing is being done. This is the experimentation being done on the UAV backward semantic segmentation. We are trying to couple this semantic segmentation along with the object detection algorithm. Reason, like in Pakistan recently we have been affected with a flood. So how much area has been affected? How much devastation has been there? Like how many buildings have been collapsed? How many bridges have been collapsed? What is the situation of highways? So we can get clear picture. Maybe at one point we can reach, but from that point we can't have an approach there. So we can use these aerial images and we can process on board to get the idea about how much collapse has been done. And there exists many data sets, like data sets for flood affected areas, similarly for the earthquake affected areas. We will use those data sets for the disaster damage effect assessment. And we are basically trying to replicate the same thing for our local environment. So there are a few more works that we did, and we're trying to do it on the, again, AI on the edge side, like human behavior analysis, anomaly detection, and lastly this one is basically a work collaboration with our UK partner, that is basically fault detection, and we are trying to do it in the real time as well as deploying in the edge-based solutions. Like we are using Raspberry Pi along with an OB device for the purpose. Then there are a few more allied applications we have been working on, like payment stress detection, multimodal speaker recognition, and then the plant drug disease detection. And finally, this is a very interesting project for us students, because in Pakistan we are having an issue of soft skill, the presentation skill. So our students are being suffered with this one. So we are trying to develop a tool that is going to assist students for their self-assessment of presentation and communication skills. And this tool is not going to assist students, but also going to help teachers to evaluate their soft skill. Because being a teacher, it's very difficult to have a clear picture about a lot of these parameters. So our tool is basically going to help students as well as teachers to have a quick assessment about the presentation skills. And this is again a totally multi-modal course is going to be there. Not only the vision, but also the audio data is being captured, and we are working in the behavior, like how the arms, leg movement, the body, the gesture, the posture is there. Similarly, what is the quality of speech is there, how many different filler words are going to be there. So this is the work we are actually working on as well. And again, it's going to be a very handy solution for students as well. Even they can have an app later on, but recently we are now just developing the website, web app for this one. So this is all from my side. The house is open for the questions. And once again, thanks to kids and you to the hall for inviting me for this one. Questions from the audience.
So I have a question. Yes, sir. Regarding the swarm, you talk about offensive. So what about the defensive side? So if we have a swarm attack, how to actually deal with that?
Yeah, this is basically a question that the few of the 20% also asked from us, like how we can deal with that particular. But that is totally a different domain. That is not basically we are trying to cover. Because for that we need some very delicate hardware on the ground station side that is going to detect that particular attack. So that we are, right now we are not testing, but recently we started a work where we can have some sort of air-to-air drone detection as well. Because people have one side where we can detect drones from the ground side, but now we started working on the air-to-air drone detection as well. One very common work recently published by, I think it was UCF group, it was basically named as dogfight, where we can detect. So this is one way to deal with that particular situation.
So another question is what happens if the leader is compromised by spoofing?
Yeah, in that case, just like we give an example, like if leader is basically having a battery issue or something like that, sometimes it's going beyond the public area as well. So we have set.
It's not going down, it's being spoofed.
So again, we have to set a priority in the system, like the other one is going to take the role as a leader. So that we have already set. Like just like going to be the face rate mode. Like in really very common as familiar with the face rate mode. So the similar thing that we have established in the algorithm, so that we can deal with that particular situation.
Failing is the condition that is detectable.
Detectable.
Failing is the condition which we have to misleading.
Yeah, but again, at one slide, I indicated about, just a minute. Yeah. Basically, this was the basically part where limited human control. Because we are not going to leave it totally open. Because the issue is that in that case, the whole swarm even can be happening. So obviously, there should be some monitoring and something that is going to be done in the ground control station. So if anything is going to happen like this one, so we are going to intervene in that situation.
One last question is, we showed the black hole, right?
Yeah.
So what is the approximate cost that we can share because all these are component based, right? And off-the-shelf component.
Exactly.
So these are off-the-shelf components.
Yes, exactly.
So what's the, can you share the approximate cost of building new something?
When we got this equipment, our company was very junior. Because we worked on the specification and the design side, and ultimately a third party basically provided this equipment. So at that time, it costed us around 750K through proper government to government channel. Like पेपर फॉलो करते हुए हमें ये लेकिन recently because even we उस company का first venture है, so they supported us in a way that if this is going to be successful, they are going to pitch the same equipment to many others as well. So later on, they took the same equipment to another institute and they were costing them too much. But it's not going to be too much costly. Even right now, if we are having a design people and we are having a facility like the major industries in Pakistan are having a CNC machining or 3D printing quality, so we can develop this kind of equipment easily. And it's not going to cost even now more than 1.2 million. Because when we procured at that time, dollar was around 154 or 55 rupees. So this is basically just a prototype. We can have much more optimized ones. Like here, we can also see why it's going to cost me. Like here, we are having just in the board along with the Raspberry Pi board. Because the machine can be tried to experiment with things, we just assume that we need both computer sources there. But when we experimented, now we are thinking like Raspberry Pi is going to be and we can remove this one as well. So we can only use the Raspberry here for the computer purpose. And that is also handling this orange cube as well.
Yes, sure.
Just showing something which is like aerial view where you look at the crowd and also mixed with vehicles and other transport.
Okay.
So can you do the analytics on crowd movement or crowd aggressiveness, crowd analytics in that?
So that we are not targeting actually. We haven't actually tested the crowd counting algorithm on the UAV side.
Counting is one thing.
Yeah, exactly. But not behavior is everything. So that we are going to do in the future. Because that is required with the large machine message.
We got this problem that.
Exactly.
Any more? Okay, let's thank the speaker. Thank you.
Now I request Dr. Amir Mahmood to present shield to Dr. Muhammad Harun Yusuf. Please, sir, come and receive the shield.
I'm doing well. मैं continuously कर रहा हूँ. I'm also having a charge at college. Also, I get TDS on this level. I'm doing that.
Thank you, sir, for your informative talk. Our next invited talk of session is Evolution of Cloud Native Computing and Open Source Software by Mr. Malik Shoaib Nasir, Technical Director at Cloud and Data Management Solutions, Huawei, Pakistan. Mr. Malik Shoaib Nasir served as Senior Solution Architect in different technology companies for 20 years, including Huawei and IBM, Pakistan. He helped different telecom, banking, utilities, and retail companies design their cloud and data management strategy. Please welcome Mr. Malik Shoaib with big round of applause.
So I'll try to share some experiences of what I have learned in the last 20 years and a bit knowledge sharing about the trends of future, what's happening in the industry. Because what I've experienced that generally there is a gap between academia and industry. But I'm also glad at the same time that UET especially is playing a great role to bridge this gap. Today I visited different stalls, there are 4 or 5 labs. So I was an expecting. So with the available resources that government is providing to academia, I think it's a tremendous that we are already doing. So thank you sir, for great contribution. So I will start with the agenda. It's a long list, so I'll skip which is not relevant. So, but first objective is to share what is happening in the industry, so that anyone who wants to use the technology, especially the cloud technology, for their projects, for their research, or for their future career, so they should have some platform, some foundation. That's the purpose of the session. So we will start with the cloud computing trends. Then there are different components of cloud technology. So we'll discuss that, primarily microservices architecture, containers, then the service mesh, serverless computing, then how this technology is affecting the data services architecture, then the API economy, DevOps, and lastly, there are different tools that different people are using, or frameworks which are using. So this is a very basic idea of how the cloud computing has evolved. First of all, are you familiar with the cloud computing? No, sir. From students, any question, any doubt? So what is cloud computing?
सर क्लाउड कंप्यूटिंग ये होता है कि हम अपना सिस्टम क्लाउड पे रन करते हैं, जो कि एक जैसे अमेज़न प्रोवाइड कर रही है क्लाउड, तो हम अपना सिस्टम वहाँ पर डिप्लॉय करते हैं उस हार्डवेयर पर, वो हमें सिर्फ एक्सेस दे रहे हैं और उसको सिक्योर कर रहे हैं। इसकी बेनिफिट हमें ये है कि हमको अपना सिस्टम मेंटेनेंस उसका नहीं करना चाहिए हमें, इसलिए हमें एक्स्ट्रा चाहिए रिसोर्सेज जो कि उसको मैनेज करें, वो अमेज़न को कर रही है, तो ये सोच है इसलिए लोग क्लाउड
So there are two most important factors. First of all, cloud provides us resources, on-demand access to resources. Second important factor is we don't have to manage those resources. These are managed services. We are just consuming those services. So on-demand access, and second important factor is the managed service, managed by third party, not by you. So exactly like utility company. If you are using electricity at your home, you don't have, unfortunately we are not giving the example of Pakistan, you don't have a power station. We just have a device that measures the utilization of that. So cloud is basically IT, I would say, information technology as a service. There are different variations of that. We will see that. What are the different variations? So it was started in 1960s. 1960s was a news for me because there is one foundation technology for cloud. If that was not there, we couldn't have used cloud. And that technology is virtualization, computing virtualization. We learned that technology was available for x86 architecture in early 2001 when we were probably so young. Lekin 1960 when mainframe was developed by IBM, they were born virtualized. They were born virtualized 1960s. So virtualization concept was there. So they just utilized that concept for x86 architecture. So second step 2001 में, when this virtualized computing was available, because we could share one physical resource with multiple tenants or multiple users at the same time. हम एक server के ऊपर we can have multiple VMs. Similarly, when you acquire Amazon, Azure, Huawei Cloud, and cloud, actually you get access to a VM. You get connected to a VM. EC2 is a VM, virtual machine. So why efficient utilization of resources? Otherwise, if there is dedicated physical hardware for every user, every individual user, then commercial cloud cannot exist. Because you cannot have a dedicated machine for every person. Otherwise, the data center would be of miles. It cannot be like a one or two rooms data center. Okay. Then second thing to discuss about AWS, they have actually commercialized this concept. The technology was available, they commercialized this concept and they made it available for the end users. Okay, in this era, up to 2010 January, it was infrastructure as a service, primarily. What does it mean? Infrastructure as a service means we provide server, storage, compute, storage, network. Primarily these three services, plus security. But there was another silent revolution coming in the computing technology that was initially in the labs, but it was actually there's a great contribution by Google to make that commercialized. That is microservices computing. The utilization of containers. That concept is also important because that technology existed since 2001 in the form of secure computing groups in Linux, but that was never utilized for the application deployment or for the application level virtualization. So thanks to Google, they also developed Kubernetes, which was a management engine, and then they made that publicly available. Now it's not a proprietary of Google. Now it's an open source technology, Kubernetes, but it was actually developed by Google. So 2014 onward, this microservices architecture or cloud native computing just started making. So in this era, there is another important player, which is Docker. Docker actually utilized this technology of containers and they started selling it or started implementing it like a virtual machine, like VMware. So commoditization of technology is very important, the commercial aspect. The technology that exists in lab and the technology that is being used in industry, there's a big difference in that. And what the company who made it commoditized, actually that company is changing the industry landscape. So Docker made it commoditized, and secondly this Kubernetes. So this combination that was matured in 2017 onwards. We call it Kubernetes plus OCI. This became the industry standard for cloud computing. In between, in 2015, there was a foundation developed, Cloud Native Computing Foundation. Actually, this is a subcommittee of Linux Foundation. So all this technology actually evolved from Linux. So Linux initially governed this body, then Google, IBM and some other companies, they started working on it. And today, there are, I think, 26 members of Platinum, okay, category, who are contributing. It's not about the devotion, it's not based on the financial contribution, it's primarily based on the technological contribution that these companies are making. So Huawei is one of those, IBM is one of those, Oracle, Red Hat, there are many companies, AWS of course. So what they are doing, actually they are providing a platform where they are developing standards for interoperability for cloud computing. So how the computing will actually work, how the containers will work, how the containers will talk to storage, how the container will use network, what network standards they will follow, what security standards they will follow. Everything is being governed or developed by this body, okay, through different projects. So these are the list of projects that they have developed. So you can see Kubernetes is now part of this CNCF foundation, okay. And now there are many other projects. ETCD, I just want to share a simple example. ETCD is like a registry. People who have done programming 10, 15 years back. So if you write a code, if you want to save some configuration on a Windows server, you actually create some registry, in Windows. So it's a key and value configuration. So it's a similar concept that we are using in this platform now. So what are the founding pillars of this architecture? Number one, microservices. Okay. Second, the PaaS technology. Third, the containers. Fourth, the orchestration engine. Fifth is the automation. Let me share one example. Then I think I'll be able to better explain this architecture. Okay. For example, we have a banking application. I'm using a mobile application, okay, for my payment transfer, for payment of my bills, okay. So there's an app that I'm accessing. Then this application is hosted on cloud. This application is connected with Nagra for the verification, CNSC verification, okay. This application is integrated with for example, Lesco for the payment of the bill, because the bank, if my bank is not giving me the electricity, they don't have the billing data. So they are just using an API connection, okay, to get the billing details. Similarly from a credit card, similar from a mobile. So this API gateway actually connects me to different components or the different backend services that this mobile application is providing. We call it super app. So because the functions or features those are being provided in that app, those are not coming from one vendor. Actually, there are multiple service providers who are providing this capability through an interface. So this API gateway. Then we have backend microservices. For example, there is one microservice for bill payment of Lesco. There is one microservice for credit card payment. There is one microservice for funds transfer. And there are different layers. So I'll explain this in the following slides. So microservices, how to develop microservices. So I think the people who have studied the computer science courses, microservices, they should be familiar. It's a very, very important basic concept. Previously, when we were developing application, we were developing large applications. Those were tightly covered. There was one big application and it has one database. What is the challenge with that? First challenge, the maintenance of that application is very difficult. For example, if we talk about the same banking application, if there is one application behind and if I am changing any code in the fund transfer, so I have to rewrite or rerun the complete application. मुझे पूरा code rebuild करना होगा and then I have to redeploy the complete application. So the big applications take hours to deploy, to upgrade. Sometimes days, sometimes weeks. The core banking applications of our Pakistani bank, those are developed on traditional architecture. It takes them sometimes weeks to update those applications, to deploy the applications. So it's very time consuming. Whereas if you use any other third-party service for a mobile banking application, it just updates in a few minutes. While instead of factory coupled components. So that if you have to change one component or upgrade one component, you can do it independently. It should not be dependent on the other components. So this software engineering principle of loosely coupled architecture, so we use that principle and then we can manage the maintenance of different components or microservices of that application easily. So here is an example, for example, this robot which is deployed under this machine, okay, it is working independently, but the one which is deployed on top is tightly integrated with the whole machine. If there will be any change happening, it is affecting the whole architecture. So this is an example of the application I'm talking about, similar application. It has different interfaces, web application, mobile application, traditional application, okay, maybe on PC, which is talking to the API gateways, and then on the backend, for example, if it's an online shopping portal or app, so there is a service for identity microservice, for example, for user authentication, second one for catalog, different type of services that they're selling, the order management, whatever order you are placing, and the basket services. So every service is independent. It's not connected with the other service. It has its own database. There's no one single database. So first step is the maintenance, because the operation of one application is very difficult when it is running in an industrial system. For example, I give you the example of core banking. For example, I am talking about the billing system of a telecom operator. There is no downtime. There cannot be any downtime for billing system because everyone is doing the calls anytime, 24 hours. I am traveling, someone is at airport, someone is at hotel, someone is at hospital. So 24 hours, round the clock, people are using that service. So if the billing system will be down, so they cannot track the billing, and that would be revenue loss for the company. The calls, those are being made at that time, that would be serious revenue loss. So billing system, so the industry needs to develop or transform their traditional application in this microservices architecture to maintain to ensure the low cost maintenance or low impact maintenance of those applications. So container, what is container? When we develop those applications, so we deploy those microservices on container. Container is a runtime environment on which we create an instance. Okay, it's exactly like VM. But VM, what's the difference between VM and container? In case of VM, the operating system is also residing in that VM. In case of container, we are doing application virtualization. There is no dependence on the operating system. Operating system is not directly connected with the app. App has its own bins, libraries, and then there is a container runtime environment. So actually this is helping us to create loosely coupled architecture. Second thing, we can dynamically move these container components from one cloud to another cloud. So we talk a lot about hybrid cloud. So in VMs, hybrid cloud was not technically possible. There were many serious technical challenges. Why? If the VM size is 5 GB or 10 GB, or if it's a big database, it's 10 terabyte, how would I move the VM from one data center to a public cloud or from Google to Azure on runtime? It will take 10 days to move one VM from the network, from one data center to another data center. So it is only possible through microservices because those are lightweight. So you can dynamically move the components from one cloud or one platform or from one operating system to second operating system. Truly at runtime without any impact. So when you have VM, when you break your application into smaller components, then you need a manager as well, orchestration engine, because there are many small components and and you need some console to manage those components, because you cannot manage the individual component at its own. There should be one orchestrator. So Kubernetes is that orchestrator. The people who are familiar with VMware, so vCenter is that orchestrator for VMs. But in case of VMs, when very large scale data center, for example, one big bank of Pakistan, one big telco of Pakistan, they have 500 VMs, maximum 1,000 VMs. But in case of containers, it can go up to 10,000 containers, 1 lakh containers, 1 million containers. There are big banks in Pakistan, sorry, in our region, who have transformed their application from traditional architecture, monolithic architecture to microservices architecture, and they are running more than 1 million containers in their data center. So how to manage those 1 million containers? So Huawei is providing this CCE Cloud Container Engine. This is a managed service for our public cloud or private cloud. Similarly, AWS, Google, everyone is providing this service. So because why they are providing, CNCF is providing that foundation. It is just a marketing package for some enhancement. The foundation technology is being provided by Cloud Native Computing Foundation. Okay. So now when we have multiple microservices, we need to manage the communication between the services. Okay. So previously we were using enterprise service bus. For example, we were talking about this example. Okay. So if different application components from different parties, for example, NADRA, for example, this we talk about the writing application, LESO, those were the external collaborator. Those were the APIs or services we are using externally. But there are many applications that we have internal. For external communication, generally we use API integration services. Okay. For internal communication, we need service mesh. Service mesh is a technology that actually ensures the communication within the data center or within one cluster between different microservices. Now next is serverless. Serverless is technically the same thing. There is only the marketing difference. I would prefer to say. This is the marketing difference. In case of IES, what do you do? In case of IES, you acquire VMs. Okay. On VM, you deploy your own operating system, and on your own operating system, you deploy your application. In terms of container, what you do? You acquire a platform where you deploy containers. Okay. Because container doesn't contain the operating system. Operating system is already at the cluster level. So you only need a management engine, Kubernetes, and you only deploy the container. And for this integration, there are few other components. One major component is the service mesh. Okay. What type of workloads you deploy in containers? Generally, the stateless components. Okay. For example, there is one cron job running. Every day, every night, there are end of day batch. What is that batch? That batch will trigger at the end of at the closing of the branch time. For example, 5 p.m. is the closing of the branch time. After that, we go for the normal banking services. So after 5 p.m., they run a batch job runs automatically. It collects the data of all the account holders and it settles a debit and credit. Okay, because we are performing different tasks. We are performing debit credits. We are doing the payment transfers. We are doing the bill settlements. So main job will actually settle the account. Okay, so that's a cron job. Cron job will run, and after it completes this settlement, it will not hold any. The data will be placed in the core banking system. So if we deploy our own cluster to run this job, we have to manage that cluster as well. What if we only use a function, okay, like an API, okay? We only use a function and the service provider is managing everything, okay? So it is a container which is being managed by the service provider. It is being managed by the service provider and it has certain life. For example, you will use it for 2 hours. Once your job is finished, this container will automatically be destroyed. Okay? So for stateless workloads, we use serverless computing. Okay, serverless is a fancy name, actually it's a container. So why we use it? It is very easy to manage the billing, because if it is being consumed for 2 hours only, or 30 minutes only, or 5 minutes only, the billing will be done on 5 minutes basis. So it's easy to understand. The businessmen, okay, they decide that, okay, there are core banking application, there are a few sources where they need stateful data, then there are certain workloads they need containers, and third category, totally stateless container, and they don't need to manage that infrastructure. Okay, so they can reduce the cost of their billing operations. Sorry, you are students, but I am intensely emphasizing this point. That is the difference I was talking about, that you must consider the commercial aspect of the applications that you are developing. Why these technologies exist and what is the commercial aspect. Okay, so serverless has better commercial value, that's why it's being consumed. Technically, it's probably the same thing. So different companies are providing this capability, just the branding is different. AWS call it AWS Lambda, Microsoft Azure call it Azure Functions, Google call it Cloud Functions, Huawei call it Function Graph. So this is the comparison. This is the virtual machine. It has hardware, operating system, hypervisor, and on top there is again a private operating system for each guest machine. Okay. In case of container, we have hardware, operating system, container engine, and then we have container. In case of serverless, actually it is exactly same, but we have abstracted the technical aspect of this technology from the consumer, from the customer. We are just providing this as a service, this API, okay, as a managed service. Okay, what is Knative? Knative is the same thing. It's a serverless technology, but they have made it industry standard. So Cloud Native Computing Foundation, they have created this standard, and this technology is also available as open source. So you don't need to buy these services from IBM, Google, Huawei, Amazon. You can easily acquire download this service from Cloud Native Computing Foundation website. Like the other open source container platform, you can also get this serverless computer. As I mentioned, we also provide this capability, and we provide this Java, Go, Node.js, Python, C#, and PHP capability with this wall function graph. Okay, we were talking about the stateless workloads. Now we talk about stateful workloads, because we have to store the data as well. So to store the data, there are different types of storages. Again, some staging area storage, some permanent storage. For staging area, we use caching. For permanent storage, we use databases, file and object storage, block storage, the different types. choice of database is available. Generally for OLTP workloads, we use relational database, RDBMS, and for OLAP, we have different data warehousing services. And in addition, we have the choice of NoSQL database, document database. So more or less all the cloud service provide these capabilities. So API, I'll spend a couple of minutes on this. This is important area because this is transforming the whole industry is working. We take the example of a bank. Today we talk about a bank. A big bank in Pakistan has 1,500 branches. Okay, and they have more than 15,000 employees. But the new era, there is no physical bank. Okay, I was part of one project where in Singapore they have deployed a new virtual digital bank that doesn't have an office, and that office that at that time completely resides in the data center. How that bank operates? If there is no branch, how that bank operates, how they make money. So this is the way they make money. API. Actually, they collaborate with different stakeholders. There are banks who are not providing the traditional loans, but they are still doing banking. We call it open bank. Different fintechs are providing different services. For example, for microinsurance, you can acquire a microinsurance on your mobile. So ABC company is providing that microinsurance. That is their one service. But in order to do the fund transfer, in order to manage the financial cycle, they need a bank at the back. Okay. So they have collaborated with a different bank. Initially they were collaborating with the physical banks. Now they are collaborating with the virtual banks. Why? Physical banks generally they charge more premium. Their cost of operation is very high. If it's a virtual bank, if I just give you one example. For example, a bank which is the branch outside the university, they will be paying minimum 5 lakhs upfront for one branch. There will be 5-10 employees working there. Their monthly operational cost will be minimum 2 to 3 million PTR. Very small branch. So you can start your own virtual digital bank. Maybe you host that bank on public cloud. You only pay 2 to 3 million PTR. The cost of one branch for hosting the whole bank in the data center. Okay? So the operational cost of a virtual bank is very, very big. So that's why even the major banks, they feel that they will have better reach due to this mobile applications. There will be more people using the mobile banking services instead of physical branches, so that there is a customer shift. Secondly, the cost of operation is low. So in the next 5 years, you will see that this complete banking will transform. In the next 5 years. It's already happening in other parts of the world. In Pakistan, it has started happening. In this year, State Bank has shortlisted 5 virtual digital banks to whom they are going to issue the licenses. And they have already started their operations. The trial run is already happening. So formally they will launch their services in next 2023. Yeah. So how is happening? Because of API economy. Sorry if I am taking time, but I think this is important to convey this message to the students. So why is happening? API economy, API gateway. So it's a technology API gateway, but they call it API economy because of this technology they can transform the technical data center to a business hub. Okay. So more or less not an issue. Since last 10 years, everyone has almost everything. So it's not like that only the Scandinavian country will have this technology, or America, or North America, or South America will have this technology. Now everyone has everything. Last topic is about the DevOps. So now we have all these technologies available. We were talking about the application components we are using. So individual components are there, service mesh is there, the development tools are there, but we have to manage the life cycle of application. Because now the bank is not a branch, now the bank is not a head office, now the bank is that application. So if that application will be down, so they cannot survive. Customer experience matters. So in order to manage the customer experience, they have to ensure that the application development should be smooth, should be fast, agile. We heard this word agile a lot. So actually, in order to implement the agile practice, we need DevOps. Without DevOps, we cannot implement the agile practice. Otherwise, agile will be in the books or in the plans only. So DevOps provide different tools from development, testing, release management, deployment, operational monitoring, everything. And then rebuild, because it's a continuous improvement. So we call it continuous integration and continuous delivery. Why we call it? Because there is no one service that banking will be offering now. One bank will be offering tens of services, and they are continuously developing those applications. Okay? Continuously developing. There is one service, generally the application rollout time in Singapore or in the developed countries is 3 days. Within 3 days, they design an application, they roll out, and they get the feedback. They feel that, okay, if this new service, customers like this service or not. If they like it, they ensure this capability. Or if that service is not good, the response is not good, they just destroy that idea. It's not like that they take 6 months or 1 year to design one new product or one new service, and they get the feedback after 1 year. It's not like that. Within a few weeks, they perceive the idea, they develop the application, they roll out, and they test the feedback. Not the technical test, I'm talking about the business test. Like if they spend like, for example, $20,000 on that application, okay, on that service, so they are getting the ROI or not. If they are getting the ROI, they will continue building that. So how it's possible? Because of continuous integration and continuous delivery, release management, operation, everything. So it's not one product. So this whole practice, there are hundreds of tools different people are using. Okay. There is one open source technology, Jenkins, that was providing this capability. It's a kind of orchestrator that was providing this capability. Okay. Now it's also part of Jenkins. Jenkins was partially acquired by Microsoft, but still it's comes under open source. Yeah. So they collaborate with different software tools for deployment, testing, where and this whole ecosystem. You see, these are hundreds of applications. Those are available on GitHub. People have developed this application just for DevOps. It is such a big market. This software in 2017 or 18, I think they sold the partial share, and that was $8.5 billion profit. Only this software. So finally, this is the example of one reference architecture of a bank. Okay, we talk about different components. For example, here is the end user who is using the security services to connect to the banking application. This banking application is hosted on the VPC, virtual private cloud. Okay, and this is actually the virtual bank I was talking about. This exactly the same thing is deployed in Singapore from Greenline Bank. In this VPC, they have this container engine. It has different pods, okay, and then Through the MQ services of Apache, it connects to the backend services and then to the database. For external services, we use the API gateway. Okay. And for the security, data encryption, compliance, all these services are available on public cloud. Okay. So this is one complete bank deployed in a virtual data center. Any question? बिल्कुल समझ नहीं आया, बिल्कुल मैंने ट्रांसलेट कर दिया या बहुत दूसरी क्लासेस का
I have you talk about the banking sector. Other than banking sector, I think telecom sector also.
Yes.
Which other sector?
Generally, retail is the first customer. Retail is the first customer. Utilities, banking, healthcare, wherever the customer are doing different application. So actually, this is the new way we are designing good application.
So Huawei has its own footprint as a data center here in Pakistan.
Not a proper commercial data center owned by Huawei. Yeah, but in other countries we have 65 data centers. Actually, we had a plan to set up data center in Pakistan. Unfortunately, because of political instability and all these issues, we couldn't do. Now we are doing it with the help of different partner organizations. There is one data center in NTC, National Telecom.
You said HAC is there.
Yes, there is plan that one.
Yes.
Yes, with HAC as well.
Education.
Yes, that's the education cloud. So, Huawei is focusing on industry-specific clouds, so that it's not just about the technology, it's about the ecosystem, it's about the domain knowledge you bring. So, if we develop an education cloud, so with Huawei has very good relationship with academia in Pakistan, they understand this domain, and they have this, I would say, the intelligence, human capital available to manage this investment. Otherwise, that investment will be wasted. So, without talent, investment has no value. So, education, why education cloud? First of all, they have students, they have partner organizations in the education industry who have that skill. So, that's why they are coming to invest in that. One area education, second, we are investing inshallah in banking. So, question.
सर ये जो सर्वरलेस आर्किटेक्चर आपने डिस्कस किया तो इसको थोड़ा डिस्क्राइब करो ये एक कंटेनर है और एक आपने सर्वरलेस.
So serverless, technically speaking, serverless is a stateless container. It can never be a stateless container. क्योंकि जब आप इसको यूज करेंगे और जब अपनी यूजेज खत्म हो जाएगी वो कंटेनर भी डिस्ट्रॉय ऑटोमेटिकली. यू कैन नॉट रिप्रोड्यूस दैट. लेकिन अगर आपको दोबारा जब भी उस जॉब रन करनी है, ठीक है, तो वो ऑटोमेटिकली दैट serverless container will trigger. So you are not managing that container. So that container, the technology part is being managed by the service provider, but the cloud service provider. So that's why we call it serverless. So serverless, that's why I say serverless is a fancy name. Technically, it cannot be serverless. It has to run on some compute. It has to run on some VM or container or physical server. But the point is, actually, you can only see the usage, the function, like you do a working takeoff. That's why we call it serverless. मैं personally I don't like that terminologies जो confuse कर देती हैं लोगों को. That's why I call it stateless.
The main reason that you don't take the server for the
Correct. Absolutely. You don't pay, absolutely. We don't pay the server or the instance. We only pay for the consumption. We only pay for the consumption.
For the CPU cycle.
Exactly. Exactly. Number of transactions, generally you service depend the number of transactions पे, number of calls पे.
सर ये जो कंटेनर है इसमें हम किसी भी लैंग्वेज को
because it only requires the container runtime. It is not even dependent on the operating system.
सर कौन से फ्रेमवर्क है जो कि ये कंटेनर के फंक्शनैलिटी प्रोवाइड कर रहा है?
आपको CMCF की वेबसाइट पे जाना, ओपन सोर्स फैसिलिटी हवा में प्रोवाइड करता है, तमाम कंपनी प्रोवाइड करते हैं।
सर अगर ये ओपन सोर्स है तो मैं तो कभी मैं मेहनत करके मैं सॉफ्टवेयर ओपन सोर्स नहीं करूँगा क्योंकि मेरा मेहनत उस पर लगा है, तो ये लोग क्यों जो ओपन सोर्स प्रोवाइड कर रहे हैं?
इस सवाल का जवाब थोड़ा मुश्किल है। कुछ बात कर रहे थे कि कुछ लोग इस इरादे से काम करते हैं हम इससे क्या गेन कर सकते हैं, और कुछ इस इरादे से करते हैं हम क्या दे सकते हैं। तो ओपन सोर्स जो है वो देने वाले लोगों की कम्युनिटी है, और आप तो देने वाले लोगों की कम्युनिटी है ओपन सोर्स। तो मेरे टीचर थे पास से पढ़ाऊंगा तो रात पढ़ा बोले वो कहते थे कि अगर ये पायरेसी ना होती तो हम थर्ड वर्ल्ड कंट्रीज के बच्चे पढ़ नहीं सकते।
शायद सर ये हमें
तो ओपन सोर्स पायरेसी को कवर करती है।
एक तो ये है कि सर हम उसके सॉफ्टवेयर यूज कर रहे हैं ओपन सोर्स, जो कि हमें लग रहा है कि ये ओपन सोर्स है, लेकिन वो बैकएंड पे हमसे कुछ बेनिफिट्स जैसे कि हमारा डिस्प्ले हो सकता है।
देखिए साइबर सिक्योरिटी एंड ओपन सोर्स to certain extent you are right, because people know all those technologies are available. Uski in-depth details are available in application, but generally it's not easy to break that. And दूसरी तरह ये कि vice versa is not true. ऐसा नहीं है कि open source नहीं है वो कभी भी हैक नहीं होता। सारे ही कमर्शियल सॉफ्टवेयर हैक होता है, सारे हर किस्म के सर्वर, हर किस्म के सॉफ्टवेयर, हर चीज हैक होती है, हर एक पे साइबर अटैक होते हैं। तो मतलब आप ओपन सोर्स को दो एस्पेक्ट से यूज करते हैं, कमर्शियल एस्पेक्ट। फर्स्ट स्टेप इज लर्निंग एंड कैपेबिलिटी डेवलपमेंट। आप उसका जो अनपेड वर्जन है ना आप उसको यूज करें। जब आप उसको कमर्शियल स्केल पे लेके जाते हैं आप अपनी प्रोडक्ट को, तो फिर आपको सपोर्ट भी चाहिए, तो फिर आप पेड सर्विस दें, ये पेड सपोर्ट है। फॉर एग्जांपल लिनक्स है, लिनक्स इज ओपन सोर्स अवेलेबल, बट कमर्शियली नो वन रन्स द अनपेड version of it. They pay the maintenance.
So let's take the rest of the discussion offline.
Yeah, sure.
So let's thank you.
Thank you very much.
Thank you, sir, for the informative talk. Now I request Dr. Amir Mahmood, please come and present the shield to Mr. Malik Sheikh. Thank you. Sir, please receive the shield. Our next invited talk of session is Smart Surveillance and Security System by Dr. Nudrat Nida from Ministry of Defense. Dr. Nudrat Nida completed her PhD Computer Engineering from UET Taxila. She received her BSc and MSc degree in Computer Engineering from University of Engineering and Technology, Lahore, Pakistan. She was awarded a fellowship for PhD from UET Taxila in 2016. Before joining UET, she was working in Comset University as lecturer and in Al-Khwarizmi Institute, UET Lahore as research associate. Since 2016, she has been working for the Center for Computer Vision Research Group, UET Taxila. Dr. Nudrat Nida won 6 national level 3 MT competitions and participated in 2 international machine learning competitions. Currently, Dr. Nudrat Nida is consultant artificial intelligence at R&D organization. Her research interests include video analytics, human action recognition, surveillance system, behavior analysis, object detection, satellite image analysis, and biomedical image analysis. She is joining us on Zoom today. Please welcome Dr. Nidratita with big round of applause.
Assalamualaikum. This is Dr. Nidratita, and I'm thankful to UT Lahore, Al-Qasim Institute, and Dr. Usman Khan for inviting me on this wonderful conference. It's an honor to be the part of this conference, and due to some official commitment, I was not able to come physically at UT Lahore. It's always felt to be at home when I'm at UT Lahore because of my parent institute. So thank you so much, UT. Smart surveillance and security system in Pakistan is my topic of talk at this conference, and it is very important topic because if we see the surveillance and security system in Pakistan is not automated yet. So we need to make an effort together to move in that direction, to strategize our youngsters, our youths, to come forward and contribute in reforming the law enforcement agencies, to reforming the government organizations, to make necessary measures to automate the process of intelligence gathering. Okay, this image is basically depicting, showing that a leopard is hunting a bear. And why this hunt will become successful? There are three reasons. If you see the eyes of leopard has a sharp vision. He has sharp eyes. He is focused. He knows his prey and who is its prey. His legs are very fast and he can run faster than a bear. Remain focused and then only he can catch the bear in due course of time. When we talk about law enforcement agencies should be fast enough, just like a leopard. They should be fast, they should be accurate, and they should have made the mission or operation in focused manner. Then only they can able to reach the culprit in its birth. So what we have to do? We have to build a surveillance system that has the capability, qualities, and ability to get the target, to get the bear as soon as possible with great accuracy. My talk will consist of these agenda items: need of automatic surveillance system in Pakistan, importance of computer vision, IoT surveillance, existing surveillance system in advanced countries, the impact of surveillance system on Pakistan, challenges and way forward. So the basic definition of smart surveillance and security system is that surveillance is used by law enforcement agencies for intelligence gathering, prevention of crime, protection of person, group, or object, or investigation of crime. So all these functions make it more powerful, will help it to be a tool for law enforcement agency, for getting the intelligence, and to protecting their own infrastructure, their own human resource. So that's how the smart surveillance will work. Why we need in Pakistan? Okay, the need comes from one of my personal experience. I would like to share one of my personal experience. Last year when I was shopping at Pari, which is one of the number one brand of Pakistan, in which I was shopping clothing with my family, and the shopping outlet was crowded, and we can imagine that we cannot stand. It was such populated that there is no space to walk inside the outlet. I was shopping. When I completed my shopping, I went to the cash counter, and there I realized that I don't have wallet in my bag. I was surprised and I was very shocked. Then what happened, when it happened, who did it? Either I misplaced it or my bag, my wallet has been dropped somewhere. So I went back to the same stall to check out that whether my wallet is being dropped on the floor or not. Then one of the person who was standing in front of the stall, he told me that madam, your wallet is not being misplaced, it is being pickpocketed by the lady. I was very disappointed. I was shocked. I moved back to the manager and requested him to help me identify the reason behind it and who are the culprits. Manager said that, madam, we are very busy, we cannot spare time for you because we have a number of customers, you have to wait for 8 o'clock when the concentration or density of customer will reduce, then we will help you to sort out the issue. I waited there, and after 8 o'clock, they helped me to evaluate the CCTV footage, the CCTVs that are installed within the shop. It took almost 1 hour. They evaluated it, and after 1 hour, by manually searching, I found that a lady who was standing, a big built lady who was standing beside me, picked my wallet from my bag. It was very disappointing. It was very discouraging for me. And all my ATM cards, my CNIC, my Pakistan Indian Consul card was present in the wallet, and the entire wallet was being pickpocketed. It's almost 1 year now, and we could not able to find the culprit right now. For me, it's very strange that computer vision expert and being a part of law enforcement agency, I could not able to catch the culprits. So what about the people who are not expert, who don't know about the technology? How they are dealing with such kind of scenario in their daily life? So this event made me realize that it is very important to have a surveillance and security system that can be able to recognize the problem and generate alerts to concerned divisions, to concerned representatives, so that they can take the necessary measures. And I was inspecting the videos just like that. I have seen multiple CCTV footage, and I don't know how to sort out this large amount of data. So their computer vision and artificial intelligence will help us to provide a secure, smart security and surveillance system for Pakistan. If we compare the security before AI technology and the security with AI technology, if we see that before AI, everything is manual, everything humans are doing it with their own perceptions, with visualizing the environment, using their eyes, and witnessing those events and then noting them. But there is more risk of manual error is being involved when it comes to detection and identification of person, crime, suspicious objects, or events. But if we integrate AI technology, it will increase accuracy when it comes to verification of intruder, crime scene, suspicious object, anomalies, and scene understanding. So this will help us to understand. Our information is limited when we do it manually. But if we use AI, we can take information from all kinds of sensors. We can get those information. And that information will help us to understand, communicate, collaborate. And when we talk of manual system, it is very time-taking, longer, and more time-consuming processes. And this will impact the overall decision-making of surveillance when it comes to manual system. But when we talk about AI-enabled security system, it will improve efficiency of day-to-day operations. So that is the edge of AI security. So why we are so confident that that can be built? Because we have AI and have two domains like computer vision and Internet of Things that work together to build a smart, secure surveillance system for Pakistan. So use cases can be, I have just written 5 use cases, it can be many more. We can use facial recognition system to recognize employees or students or suspicious person within any area, within critical area or any campus or any city. Then person tracking, we can track the movement of person who is moving from Karachi to Quetta with the help of safe cities by using the facial recognition and person tracking. Then we have crime detection, suicidal attacks can be detected, the behavior of persons can be detected, events like robbery, arson can be detected, suspicious object can be detected like bomb planted underneath the car, unattended baggages. Action and event can be detected like entry in no-go area, a person who tried to enter or forcefully tried to enter a campus or an area. Alerts can be generated and records can be kept. Similarly, the person who is moving in the airports, the person who is living in Pakistan and who is going abroad, there should be a proper database to recognize them and to maintain their records, that who are there, what are their back checks. So everything should be be logged and it should be ongoing. The ease of computer vision algorithms make us confident that these things are possible. Like the facial recognition system, we can use visual transformers, face band, and many more algorithms to recognize the faces with 99.9% accuracy. Then we have person tracking. We have YOLO V4, V5, V6, V7. And with GSOT we can able to track them. We have Kalman filters. Then in case of crime detection, we have ActivityNet, vision transformers are there to help us. Then we have OpenAI to help us in crime detection, also suspicious object detection. We have all of the detection algorithms like RCNN, faster RCNN, YOLO, digital vision transformers. So these all will help us and facilitate us because they are very good in recognizing objects. Similarly, for action or event detection, we have digital or OpenAI to recognize the action or events. Existing surveillance systems in advanced countries like Malaysia, Russia, and Germany and China are very advanced, and they are using the capability of computer vision and Internet of Things to automatically perform the surveillance using CCTV footages. Impact of surveillance and security system in Pakistan protecting the citizen and infrastructure is top priority of any government, any country. So that is the prime objective. So that will be the after deployment of smart surveillance system, this will be the control room that getting the information from all the CCTV camera deployed at all the corners of the system. Okay, benefit of Pakistan security. So there are multiple benefits like it increases efficiency and productivity, more efficient operations, higher productivity lead to success and expansion. Boost intelligence encryption, the right tool encourage security agencies to extract information in better way to do surveillance operation, improve management, system and platform, keep the organization organized and on track to achieve security provision goals. So, by looking at challenges, I would like to share one of the joke with you in which a person who was driving in safe city Lahore and the speed was 100, and when he came across the camera of safe city, the same speed camera flashes. So he thought that my speed limit is not very high, and still that same speed camera counted me in violation of traffic rules. Then when this crossed, he take another round and come in front of same camera. The camera refreshes, and now this time the speed was 60. Then he smiled, and to make it more enjoyable, he take another round, the third round. And this time the speed is 40. And then again the camera flashes and takes third picture. He laughed and he said that they think that AI will take over the world. They think that AI can detect the violation of traffic rules. That's not possible. How can it be possible? He laughed and he went home. Next day, when he get up from the bed, he checked his email and he received 3 emails from Safe Cities Authority. He opened the first email, he found that it was written that he violated the traffic rule that he haven't fastened his seatbelt. Then he opened again, and the third email was saying the same. He said, I was wrong at that time. See, the main concept is that technology is there. We have to be intelligent enough to make sure that we use accurate amount of technology, we use this technology to make it possible. We have to trust the time, we have to trust the resource who are developing. And these things will become realistic one day. So we have to put effort in right direction. It's our duty to utilize our knowledge that is being given to us by our mentors, by our institutes, and we have to utilize that in right direction. And our policy is always doing very good effort in right direction, and we are contributing a lot in it. So what are the challenges in adopting the smart surveillance security system? Is that hardware and infrastructure cost. So we have to deal the cost of hardware, because if you install the CCTV footage, if the wrong people snatch your camera or destroy it after committing a crime, it will be very difficult for you to collect the evidence and to reinstall the camera having safe capability. We have to check the resolution of the camera, that its resolution should be 30 meter, can image or it can capture the face or images of 20 meter. Moreover, we have some good data centers to acquire the data and keep it for long term for record keeping. So all these infrastructure costs is there. Ensure security of all our models that are deployed on edge devices, on servers. We have to ensure the security. We have to ensure the security of the input devices, the CCTV footage. We have to check that there is no violation in building the model, no biases are being added in the model. So we have to ensure that there is cyber security is being present in developing a secure security system for Pakistan. To mitigate the risk of face spoofing and adversarial attack, we have to check and ensure that our system and our models are advanced and they can able to mitigate the risk of adversarial attack. We have to boost every team line and mode of communication to take necessary action whenever there is a red flag, whenever there is an alert generation. So we have to make a synergized effort. We have to make sure to retain and support Pakistan culture. We have to look after the privacy concerns of the people of Pakistan. The privacy is very important. So what will the way forward? Will the smart surveillance and security system become the new norms of security? Yes, it is. Smart surveillance and security system will allow law enforcement agencies to empower with how they conduct surveillance operations. It also presents them opportunity to rethink their strategies in a way to become more efficient, more cost-effective, more sustainable in long term. Privacy of citizens must be considered when designing the architecture of surveillance system. I will conclude my talk on the saying that technology is nothing. What is important is that we have a faith in people that they are basically good and smart. And if you give them tools, they will do wonderful things with them. This is the saying of Steve Jobs. Thank you so much, Al-Muazni. Thank you so much, Dr. Sanaliman. Thank you so much, UAE Lahore, for inviting me, providing me this opportunity to talk with this wonderful audience. And if you have any questions, you are more than welcome to ask me. Thank you.
अभी सर अवेलेबल थे डिस्कनेक्ट हो गई
Okay, so any question from the audience? You can convey over the Zoom. Any question from the audience? Regarding surveillance or security?
इंटरनेट हो गया सर इंटरनेट हो गया हम सबका चल रहा है मेस कनेक्टेड नहीं है
Okay, then let's thank the speaker.
Now I request Mr. Amar Yaqub to present the shield to our session chair, Dr. Amir Mahmood. Please, Doctor, come and receive the shield. Please clap for the. I hope this session was engaging for all of you. I want to offer my thanks to our session chair, Dr. Amir Mahmood, and all the presenter and audience. With this, I officially announce the closing of the session. Thank you. Thank you, everyone.